AHSA in Victoria. Our guest speaker tonight is one of our members, Squadron Leader Roger McKay, and I will introduce Roger at a later stage in the proceedings. But first of all, I'd like to introduce David Prosser, our president, and he will open our meeting. Dave? Can you hear him? No, just okay.
Thank you for being on the Zoom meeting tonight. A bit unusual, but nevertheless, Squadron Leader Roger McKay, and now an executive jet pilot as well, and a very great introduction through the evolution of fighter aircraft in the RAAF. And this promises to be a very, very interesting discussion. Roger having flown a number of these types over the years, and he'll continue on all the way through the discussion from the Vampire all the way through to the F-35 strike fighters and the new generation fighter. So, as they say, lay back, enjoy, and you'll get a good education on RAAF fighters past and present. And Roger, highly experienced jet pilot, more than 40 types and 2 decades in the RAAF. And Roger will be discussing those tonight. Roger, welcome aboard, and thank you very much for donating your time to be with us tonight. And I'm sure that the members present will be both educated and become more knowledgeable about RAAF fighters after the end of your discussion tonight. So welcome aboard, and thank you very much.
Okay, thanks, Dave. Roger, it's all over to you.
All right. Well, happy to see everybody here. We're all getting used to these Zoom meetings. I do others with some of my other associations, and certainly also with some of the work commitments I have. It's not working too badly, but presentations in particular tend to turn into a bit of a slideshow. So please, by all means, stop me along the way and ask questions, and we'll see how we go from there.
Is everybody on speaker's view?
Say that again.
Is everybody?
Yes, I do.
Good.
Okay. I'm actually up in Queensland. I'm stuck up here. I've been flying a corporate jet for one of our captains of industry since last October. My first permanent job in about 15 years. I don't think my timing could have been better. It is so good to have a pay packet every week instead of waiting for the phone to call to see where your next gig was going to be. So I'm very grateful for that, but I've not been won over by Queensland just yet. So I'm sorry if there's some Queenslanders amongst you. I've been out these last few days working at Queensland Airport, and I was there on Sunday when the airport opened and saw the two P-51s and L-39 and a few other warbirds flying around. And today we were out there as well, and I had the chance to see the last Qantas 747 take to the sky once again. My favourite airliner, if ever I was to have a favourite airliner, it'd have to be the 747. I need to correct that publicity blurb that went out on my behalf. I'm actually just over 46 years in the Air Force, and believe it or not, just a month ago I was posted again from Headquarters Air Force Training Group after 20 years as a staff officer over to the cadet branch. Some of you may be interested to hear that one of the previous chiefs of the Air Force saw great merit in trying to indoctrinate the cadets, and went ahead and they bought a dozen or so odd Diamond DA-40s with diesel engines. They'll be spread around Australia, and the aim is to try and convince some of these young folks that the Air Force offers a brilliant career. I'm sure Mark, I know Mark's had a pretty good career in the RAAF. I'm not sure if any of the other viewers have also had RAAF careers, but I'd certainly recommend it. I'll just hit now this share screen and we'll start the presentation. Let's see if I can do this properly. Where is it? One second. All right, all of you should be looking now at a very early first generation jet engine.
No.
Yes,
Okay.
nothing yet, Rog.
Nothing yet. Oh, well, hang on just a minute. I did hit share screen. Let me just try one more time. Where's the Zoom? Share screen.
Cancel all the microphones, Robert.
Here we go.
Yep.
Better.
How's that?
Ah, lovely,
Terrific.
lovely.
We've got it.
Fantastic.
Okay, well, it will come as no surprise to many of you. You'll know the name Frank Whittle. And this, of course, is one of the first jet engines ever built. And just to stipulate, the topic of my brief tonight was to be jet fighters, was to try and explain. Some of you have heard that we're buying a 5th generation fighter. And I thought we'd just delve into what those generations mean in fighter terms. A topic of what the Air Force had by way of fighters, as Dave announced, that would go on for hours. It would go on for hours. So what I'm going to do tonight is just talk through how this term generations of fighter applies. And it's really only a relatively recent way of categorising the fighters and other aircraft. Let's start with the first generation of jet fighter. And clearly they came about during the war when old Frank Whittle, notice that Frank Whittle, I think he made Air Commodore, developed this jet engine. And I'm hoping that you'll be able to see the little arrow there.
Well, we got some, excuse me a sec, Rog. Excuse me, we got all the background noise. Can we?
You need to cancel the microphones, Robert.
Yes, I know, but I can't get back on that screen. And I'll cut Roger off as well. Hang on.
Everybody please mute themselves.
Can everybody please mute your microphones, please? Good. Okay, that's better. Roger, all yours.
That's it. All right, well, let me just go back one there, and I'm hoping you'll be able to see. I might be telling you something you already know. Can you see that arrow I'm using to point?
Yes.
Okay, well, this is where the air came in, believe it or not. It didn't come in through the front, as you might suspect, but through this air intake, and it's obviously has a mesh there to stop foreign object damage, and it had basically a single centrifugal compressor that compressed the air, fed it into these combustion chambers where it was mixed with fuel. There was a continuous fire going in there, and that energized air came out over the back of a turbine which had a long shaft that came through and powered the compressor. Now, some of you may have seen those the films about these early jet engines. They had a lot of trouble controlling the RPM and exploded quite a few. Fuel control is a big thing in jet engines. It still is, and we'll see how this may have affected some of the engines. A lot of them nowadays, of course, are controlled by computers, but that wasn't available in the World War II era.
Roger, you didn't actually specify what engine that was. That's an original Whittle, is it?
I think so. Yeah, I think so. I can't remember when I put this package together. It was some time ago, and it's not so important that we identify, but rather that that's the sort of engine that was used in these first jet fighters. A centrifugal compressor, just one stage. They had heaps of power and obviously went very fast, but they had big problems. Instead of the 3 or 4 hours much longer for some of the big long-range fighters like the Mustang, P-51, P-47, P-38 Lightning, these early jet fighters had endurance in the order of an hour. Very little, but they had massive performance, and obviously the thrust to take them up to very high altitude. So the Allies persisted. This one is an early Gloucester jet. And of course, some of you may recognise that those, I know it's a little bit fuzzy, but they're Meteors who also use Rolls-Royce centrifugal compressor engines. 2 engines. They did certainly increase the speed of the aircraft, but if you have a look just here at the front of the aircraft, you can see they're still using guns and still straight-winged fighters. So they didn't have as much performance as they would in later life. But clearly these are slightly later meteors, and they've got drop tanks there. That one there is also a very early generation fighter. It's a Vampire. We used them in Australia, or rather the Royal Australian Air Force used them. I don't think we had them on home soil. We used them in Malta, and we leased those in the after-war years. Again, with a centrifugal compressor engine, great performance. They went to altitude, and of course, some of them were pressurized. They used the pressurized air to put air into the cockpits. But still, these first generation fighters had basically straight wings, lots of power, used up lots of fuel, but still relied heavily on guns to shoot down enemy aircraft. This one is a modified Vampire. The Vampire was modified for a two-seat, turned into a two-seat trainer. And Royal Australian Air Force and other air forces used them very successfully for many, many years. This was the precursor to the McKay over in Pearce. I was involved with Timor for a little while, and we have a twin-seat Vampire up there. Some of you may have seen flying. It hasn't flown recently, but I heard the other day they may be getting it back into the air. It reminds me of a story one of my old COs had told me. He was Robbie Robson, and he was a Wing Commander CO of 36 Squadron, the Hercules Squadron. He had joined the Royal Australian Air Force, having come out from the Royal Air Force. He was a fighter pilot and had joined the Royal Air Force just after World War II, or a little while after World War II, and been posted on to Vampires. And he was in those single-seat Vampires like we just saw on the slide before. And he was loud-mouthed and young, and it couldn't be beaten, and was in the bar one night having a discussion with some of the old and bold World War II pilots. His squadron, Robbie's squadron, was converting from Spitfires to Vampires, and he told the story how he had a bet one night in the bar that the next day they would have a climb to height, a challenge. And Robbie used to tell the story how they'd lined up together on the runway, and the flag dropped and off they went. And as expected, the Spitfire got airborne very quickly and started to climb. Robbie got airborne a little while later in his jet and slowly caught up with the Spitfire in the mid-teens, 17, 18, 19,000, and off he went. He thought, right, I've got you now. I'm heading for the sky. Only to see a short while later that the Spitfire had gone from first to second gear with the supercharger, whereupon the Spitfire just pointed his nose up into the heavens and soon overtook the Vampire. So the jet fighters of the era, the first generation fighters, they certainly weren't invincible. They had great performance, but still some of the big fighters had similar performance and certainly much better endurance. They persisted. The Brits weren't alone with jet fighters. There's an early Japanese jet fighter. A lot of them went with two engines. The engines weren't reliable, and they used two engines to get that extra thrust. And of course, the Germans. The Germans really were probably at the forefront of these developments. And some of you will recognize some of these fighters. There's another twin engine one. And of course, there's the American one made by Hughes, I think it was. I can't quite. Bell, that's it. And it looks like an interesting fighter. I'm not sure of the performance, but the one I really wanted to show was this, because this signified the sort of end of the first generation and the beginning of the next one. The Germans realised the value of swept wings. And whilst the first generation of fighters were somewhat limited by their straight wings, whilst they could climb higher, they could go a little bit faster than most of the piston engine fighters, they were limited. The Germans were well ahead in aerodynamics and in fact also ahead with rocket power. I wonder whether this thing ever went supersonic. I'm not sure if it did. But I don't know why it wouldn't go supersonic. It might have a bit of drag. Certainly, it was very limited endurance. It used rocket power, the little Comet.
It didn't have enough fuel to get that fast.
No, I didn't think so. So this sort of starts to point towards the beginning of the second generation of fighters, where the power of the engines was there, but the aerodynamics weren't keeping up. The aerodynamics that the Allies and others learned from the German spoils of war led to the beginning of the second generation, where the swept wing came into its own. This is a MiG-15, and I was lucky enough to fly the trainer version of these, and remarkably, it was extremely docile. A highly swept wing, but you'll see on the wing there are two big wing fences on each side. The stall in this was far gentler than it was in any Cessna product that I've flown. It uses a pressurized cockpit, and there are a lot of British aspects of this aircraft that the Russians must have picked up from during World War II. It used a nitrogen bottle to store pressure for the use of the flaps and the brakes. And this still had a handbrake with differential rudders to control which brake came on and which didn't. And that was how you steered the thing. It was extremely robust. The gear indicators were given by mechanical pointers that popped up in the wings and in the nose of the aircraft, just where the pilot would see it. It was a delight to fly, a delight to fly, and had a lot of performance. That's a good photo there of the twin-seat version, but shows those wing fences that got rid of some of the characteristics of a swept wing. You can see there it's carrying some external tanks because fuel usage is still a major problem with jets, especially these early ones. And here's the American version, the Sabre. You can see the wing is highly swept.
Okay.
Interestingly, they were still using guns all the way into the Korean War. The engines had developed as well. They started to develop, and let's see, there's another Sabre shot. The engines had also developed, and this is just a diagram of how things had changed. Instead of the single centrifugal compressor at the front of the engine, this one used multiple compression of the air. And quite often, the early stages of the compression were where the air was picked off to feed into the cockpit to pressurize the cockpit. Far more reliable and far more powerful than the early ones. And of course, in the exhaust here, we'll find that to gain even more power, they poured fuel in, and hence the term afterburner. The raw fuel was pumped into the exhaust, was ignited, and gave additional thrust, but again, at great cost to your endurance. I've seen some of these MiG-17s, MiG-19s, this is a MiG-17, I think, single engine, flying over in at Oshkosh. I'm not sure if anybody's had the luck to head over there. That's a MiG-19 with the two engines. We marked the sort of end of the second generation of fighters, and let me say that the boundaries are a little bit grey. They're not necessarily rigid. With the advent of heat-seeking missiles, this is a much later version, an air intercept missile 9X. The early ones were nowhere near as advanced. They used a seeker head here that was cooled and could differentiate the heat exhaust coming from the hot exhaust coming from the enemy aircraft. Fighters had to position around towards the tail of the aircraft for the seeker head to capture that heat coming from the leading edge, or sorry, from the engine of the enemy aircraft. They were called sidewinders, because with the rocket motor, they went very fast, the burns were quite quick, and then they were gliding. But these vanes were sort of massive deflection. They would just deflect one way or the other. And here are the other two. There's one hidden here. So they either went up and down or left and right, and left a bit of a corkscrew trail towards the enemy aircraft, hence the name Sidewinder. They're a short-range missile, and usually around the 1 to 2 mile mark would have been around the limit, unless you had a really big exhaust or a lot of overtake speed. But this marks the end of that second generation of fighters, where not only were they getting much more powerful from the axial flow compressors and more aerodynamically fast with the swept wings, but also we started to see a push towards missiles. Sidewinder or heat-seeking missiles came in later in the Korean War and were used to a great effect. The aircraft was still fitted with guns though. And of course, a lot of the early fighters only carried 2 of these missiles. And obviously, if you poop them off, you've got to resort to guns if you need to do your job. And so here we come towards what is generally considered the third generation of fighters. These are very high-speed aircraft, twice the speed of sound. They carry guns, they carry missiles. I'll get more into the missiles shortly. But more importantly, although not on this one, they carried a radar in the nose. That radar in the nose enabled another jump in weaponry to radar-guided missiles. This is a MiG-21. Generally considered the adversary of the Allies or the Westerners, Western Bloc. It is built in huge numbers. Tens of thousands of these were built. It's very fast and it's very potent. And as we found out at Williamtown when we were flying a two-seat version, it's very capable. It's fitted with a nose wheel brake, so it could actually operate off quite small strips. You can see there, this is an upgraded version. It's been fitted with additional missiles, and I'll get to the missile shortly. Here in the black nose is the air intercept radar. A Crusader, these Mach 2 capable aircraft were actually ship-based, and you can see this one, although it's a bit fuzzy, has the variable incidence wing jacked up for its takeoff. The afterburner is showing, very capable aircraft. Apparently Australia nearly bought these. Here on the side of the aircraft, it's not distinct there, we'll get to it a little bit later, is one of those missiles, a heat-seeking missile. And here, in fact, is a cockpit that the pilots were faced with in the late 50s and early 60s. You can see a lot of gauges there, but importantly, up here you can see the radar scope that the pilot would have used to try and pick up enemy aircraft, generally after being vectored onto them by some air defence controllers. More often than not, they would try and vector you for a stern attack, but with the advent of the later missiles, a head-on attack. Generally, the radar-guided missiles would be good for around the 5 to 6 miles in the early days, head-on. And this is, in fact, the Mirage cockpit. I'm not sure if Mark had a chance to go for a ride in one of these, but you can see it's a very busy-looking cockpit. I can tell you that at the time, we didn't think it was. Everything has a purpose, and you'd only look at one thing at a time, of course. But here is the radar scope in the middle. Generally, that would have a rubber hood around it that the pilot would put his head down into to try and spot the enemy aircraft with the radar. Inside the radar scope was just a very rudimentary depiction of the attitude of the aircraft so that you could keep your wings level. And this This is a later version. This was the best photo I could find of a radar-guided missile. It's an AIM-7 Sparrow, and this one was fitted to the F-18 Hornets when we bought them. The Mirage had a much earlier version of the radar-guided missile, not quite as capable. The normal fit for the Mirage was 2 Sidewinder missiles, which were upgraded as we owned the aircraft to more capable ones, and a single radar-guided missile under the belly of the aircraft. As we got towards the end of the life of the Mirage, the Sidewinder missiles, the heat-seeking missiles, were upgraded to such an extent that the nose could actually pick up the heat generated from other parts of the aircraft through the skin. It wasn't capable of a head-on attack, but certainly at the 90-degree mark, you would get tone, and the missile could differentiate. When we went over to these later model AIM-7 Sparrows, they were first seen probably in Vietnam on the F-4s and other American aircraft. They're a bit longer range as well. And you can tell by just the size of the thing, it's obviously much bigger. It's got a bigger motor and would home in on the radar energy generated or reflected from the enemy aircraft, and that radar energy was generated from the nose of your fighter aircraft. The F-4 was a bit of a brute of an aircraft, and you can see he's carrying not only some missiles, but also some bombs. And this starts to give rise to the next generation we're going to talk about, a much more capable all-round aircraft, a multi-role aircraft, in fact. And the governments loved these multi-role aircraft because they could just reduce the number of aircraft. It didn't quite work because you couldn't be in 2 places at once. But this is a massive load. You can see that there's some, under the fuselage there's some radar-guided missiles, and out on the wings, you can see some heat-seeking missiles. Interestingly, this aircraft does not have the gun that was later retrofitted and fitted to some of these F-4s. This fellow is obviously going in to drop some bombs as well, and has the ability to defend itself rather than rely on other aircraft to defend while you went on to attack. This aircraft was indicative of a feeling at the time where they fitted 2 people to the aircraft. The task of flying the aircraft through enemy defences, especially at low level, and also controlling the weapons, controlling the radar in the nose, was considered so big that they put 2 people in. We used this system in Australia. We had F-4s for a little while, and then the F-111s that Mark went on to fly. And certainly in the early generations of these aircraft, without the automatics to assist, it was definitely a 2-man role, and that's why we did it. Interestingly, as we've seen, the F-111s have been replaced by Super Hornets, again because of the complexity of the task. So here we're starting to get into a 3rd generation where the aircraft are fitted with all-weather capability. They're fitted with radar-guided missiles, and they're becoming multi-role. That's another Phantom. Here's one that's starting to drop bombs. The Phantom was widely used around the world and was only just retired. I forget who it was last using them. Greece, I think it was. The other thing that we saw during this generation of fighters was the advent of air-to-air refuelling to address that biggest problem, not enough fuel. We did not have tankers in Australia for many, many years. The Mirages that we flew and were sent off to Pakistan were fitted with refueling probes. I wish we could have done that. It would have made things a lot less stressful. It's very stressful when you come back and you've only got 10 minutes of fuel left. Air-to-air refueling, these are Navy refuelers. The Navy have used this probe and drogue for some time with great success. This is a British one, and this is a later one where they're using a modern aircraft. similar to our multi-role tanker transports. This is a British one, feeding onto some tornadoes and a typhoon up the top here. It's a little bit more difficult from what I've seen to refueling from the boom and receptacle, where there's a tail boom that drops down and is driven into your receptacle. But this is a bit less complicated, I guess. And obviously with two on the wings, if one goes, you've still got the other one to use. There you can see the view of an F-18 coming in to refuel. Most of the refuelers now don't have an operator parked down in the tail. They're controlled by the cockpit with a fellow boom or a refueling controller with a camera. It's interesting to see that that F-18 does not have symmetrical stores. There's a fuel tank on one side and not the other. I hadn't noticed that before. The other advent I've talked about just briefly is how these third generation of fighters became and were heading towards multi-role aircraft. This is the F-105, which was originally designed as a nuclear strike aircraft. It had a 30-grade big bomb bay in the centre. It's a massive aircraft, basically about the same size as an F-111 with just one pilot, and they were designed for one-way missions, I'm told, in Europe during the Cold War. They were used in Vietnam in large numbers as ground attack aircraft and strike aircraft because of their speed and the ability to carry loads of bombs. One of my favourite aircraft, I must admit, the F-105.
Got lost in large numbers.
They do.
Very much.
And now we're sort of moving towards fourth generation. Some people might call it still third generation. I like to differentiate because with the fourth generation, we see the multi-role capability still there. We see air-to-air refueling still there. But what we're starting to see is an upgrade of the actual fuselage, the introduction, if you will, of composites and fly-by-wire. That they distinguish this generation of fighters from the one that went before. With composite material, they achieve strength with low weight. But they also achieve with composite material fantastic ability to withstand battle damage. We've, some of you folks may have seen aircraft coming back either with battle damage from somebody trying to shoot them down or a missile, or after being involved with a collision. The ability of the aircraft to continue flying is testament to the strength, the remaining strength of the carbon fibre and materials, but also to the fly-by-wire. With fly-by-wire, as you're probably aware, the control column is not connected to the control surfaces, but rather is your means of talking to the computers, the flight control computers. I've had various people come back, various friends come back with pieces of aircraft missing, large slats or flaps gone. And the pilot said, apart from just a very light jolt, they didn't notice it. They didn't notice it, which is quite remarkable, really. The other thing that has progressed with these aircraft, they carry the all-weather missiles, the Sparrows and their derivatives thereafter, but the heat-seeking missiles, which these aircraft still carry out here on the wingtips generally, have now been supercooled and have the ability to be fired on an enemy aircraft head-on. They can differentiate the heat signature from the background in a head-on situation. Quite remarkable. This, of course, is an F-18 designed initially to be operated on and off a ship, but operated by the Royal Australian Air Force, and just coming into its retirement it's been a fantastic aircraft, exceptionally reliable, exceptionally tough. One of the big benefits of it being designed to operate on a ship is that they're finally designing aircraft to be maintained. And being a ship-borne aircraft, they don't like carrying loads of ground servicing equipment. So much of the equipment can be tackled and worked on at chest height. Where are we? And of course, with the advent of the next generation came the next generation of cockpit. You can see here, this is an F-18 cockpit, and the primary flight display is up here on the heads-up display. You have other screens that allow you to select various weapons that show you navigation, and of course, inertial navigation for a little while, and then the use of satellites has been introduced. Much of the missions are pre-programmed before you walk out to the jet, and you'll load a cassette that you've pre-programmed in the operations room or somebody else has into the jet with all of your tracks, with all of the intelligence of where the enemy is, etc. All the radio frequencies. These are much easier to fly, heavily reliant on automatics. And because of the fly-by-wire and the carbon fibre, extremely aggressive, far more agile than the third generation before them. We started flying the F-18s, most of us were Mirage pilots, and it was remarkable the things you could do with this. It didn't fly like the aircraft we've been taught to fly. We did start to fatigue the tails because we were just enjoying the manoeuvrability, the agility so much. And so they've wound the manoeuvres down a little bit when you're just transiting or whatever, but a very aggressive aircraft. The Allies, the Western Bloc, were not the same. In the East, the Russians in particular continued to develop aircraft using very similar technologies, and yet they didn't go over to fly-by-wire or carbon fire quite so quickly. They continued to develop some of the previous technologies. Steel work, they used, in fact, engine nozzles to vector so that they could achieve the agility. They used massively powerful engines and were able to maintain parity.
MiG-29.
And there's another one. Big aircraft, very powerful, big radars, and you can see up here some of the sensors that started to come along with this generation of aircraft. IFF interrogators, you could look at the aircraft around you and you could tell whether it was friendly or not by what codes it was sending out. Some of them also started with the F-18s, fourth generation. We started to see infrared seeking devices where you could look much longer range than previously with low light level and infrared heat seeking televisions or seekers, and you could actually switch the radar off. This was a good thing in many cases because the radar emissions gave away your position and what type of aircraft you might have been. But if you ever get a chance to see one of these Russian fellows perform at an air show or even just on YouTube, it really takes your breath away. Interestingly as well though, many of these aircraft still carry loads of weapons and missiles. One of the biggest problems with the F-18, apart from still not having the range, it was better than the Mirage but not as good as you would want for Australia, was that it carried a limited number of missiles. You can see how many, I don't care to count, so many missiles on this aircraft, but if you're flying towards an enemy, the difficulty is, of course, if somebody fires a missile off towards you, you have to react to it. You can fire missiles at one another, but if you only have 4 and he has 8, he's going to win. I'm glad I didn't fight against any of these aircraft. You can see how the aerodynamics of the Russian aircraft has gone in a slightly different direction to the Allied aircraft. Massive engines, massive radars on the nose. They're still designed to hunt out enemy aircraft, but the thrust vectoring on the engines really is a remarkable situation.
Rear facing radar too.
Yes.
That one, SU-27.
Amazing aircraft.
Very big.
So this is the sort of 4th generation aircraft we're looking at there. And they started to really up the ante. We did see some very early airborne early warning aircraft in Vietnam with radar based on the top of old piston engine transports. But this technology evolved. And now you really can't have a fighter force without having some sort of airborne early warning device. This would feed information either verbally through controllers in the back or in later stages by data link without voice communication to the aircraft. In the F-18, we had that capability to take information from an AWACS without voice communication. We just didn't possess the technology, the AWACS aircraft themselves. We do now. This is the wedge tail, and it's starting to point towards what really is the 5th generation of aircraft. There's so much computer power flying in the skies today, so much ability to see what's happening around you, that the flood of information represents what is part of this 5th generation. We saw it a little bit with our modified Hornets, the F-18A and B that we had as fighters to replace the Mirage. We see a little bit more, far more capability, in fact, with the F-18s that replaced the 2-seat F-18s that replaced the F-111s. And in fact, the addition of the squadron of Growlers to suppress enemy air defences represents the pinnacle of how this information is passed from one aircraft to another to give the crews a picture of what's happening around them. And of course, to give that picture by satellite or ship to the commanders who are making decisions. And of course, now we can refuel these things so they can stay airborne a long time. A real force multiplier, not just by having this information up ahead where the fight is, or being able to control your fighters far more easily, but by air-to-air refueling means that we don't have to have so many of these aircraft out there and around. We can refill them and keep them on station for much longer. So now we're starting to get towards, I think, in my mind, the 5th generation of aircraft, and they are those that have been designed to be stealthy, to be not seen so easily by enemy radar. The F-117 was obviously flying around for a number of years before it was used in anger, and it did amazingly well. The current crop of 5th generation fighters, like the F-35 that Australia is buying and is proving very popular, not only represents a step up in performance to some extent, but a major step in technology. The advent of the automatics that are in use by the pilot in this aircraft remove a lot of the workload that he would previously have had. Targets will be prioritised, not necessarily by the pilot, but by some of the automatics or by the picture that he sent from elsewhere. Carbon fibre again, massive speed, and the ability from the engines now to super cruise, to cruise supersonically in dry power, in fuel mode, without having to use the afterburner and gobble the fuel. Time will tell. We've been very lucky in Australia with the choice of our fighters and our attack aircraft. The F-111 served for many, many decades, a number of decades. The F-18 is just being retired after 35 odd years, and we had a similar run with the Mirage. Fingers crossed. There's one thing that I'm not so fussed about with this aircraft, and that is that it's only got one engine. Be a lot of money to lose if one goes down. You can see there's a lot of smooth surfaces there. It's aimed to be stealthy, although carrying these pods underneath is not going to help. This one's the Raptor. It's obviously an air supremacy aircraft. Their aim is to control the skies, to deny any enemy use of the skies in any way, shape or form. Massively expensive, hugely powerful, and a flying computer. So where's all this going to go? It's an interesting tale. We're now starting to see things like pilotless wingmen being discussed. We're seeing a much greater reliance on drones to surveil and to deliver weapons, to deliver bombs and other weapons to targets on the ground. I'm not sure whether manned fighter aircraft will continue going into a sixth generation. Only time will tell. That's it for me, folks. Are there any questions?
Yes, Roger, I've got one.
Gordon.
Can you hear me?
Yes.
Roger, Gordon Clark. You mentioned earlier on that Australia almost bought the A7 Corsair. I was wondering when...
No, the F8 Crusader.
F8 Crusader.
Oh, sorry, F8 Crusader.
Yes, I believe they looked at it briefly. They also looked at the F104, and they also looked, I believe, at the Lightning, the British Lightning.
English Electric Lightning, yeah.
Yes, I don't think the Crusader got a serious look in. I think it came down quite quickly to towards the Mirage as being the preferred aircraft.
Right. So the F8 Crusader was on the table for the RAAF, then not the Navy.
Yes, that's correct. That's my understanding. They're similar generation, similar performance, but they went with the Mirage. The Mirage is a fair bit smaller than the Crusader. The Crusader is a very big aircraft. And I think one of the things they were talking about that may have figured into the equation was that they fitted an Avon, Rolls-Royce Avon engine to one of the Mirages. And I think that might have been part of their thinking. The other was that we ended up building Mirages in Australia after the first few arrived. So that may have also been a factor. I'm not certain.
The Mirage had low pressure tyres because the Crusader did not. And it wasn't multi-role either.
Well, the Mirages we bought initially were not multi-role.
No.
We modified them from 3A to 3O relatively early in the life and gave them multi-role capability.
Roger, you once told me that the Mirage is your favorite aircraft. Why was it your favorite aircraft?
The favorite is an interesting word. It was the first fighter I flew, and it was extremely exciting. But I'd say this, that if I was going for a hoon in the low flying area, I would take a Mirage. If I wanted to do aerobatics, then I would take a Mackie. If I unfortunately was sent to war, I'd want to be in something at least as good as the F-18. But if I just want to put a smile on my face, I go and climb into my windshield. And of course, the windshield's perfect for taking a girl out to a picnic or something because she's sitting beside you and you can chat.
Roger, I've got a question here from Dave Prosser. Dave, can you?
Sure. Roger, good evening. Dave Prosser again. Roger, you've discussed very interestingly a number of the aircraft that the Air Force has had, but the question I've got for you, if we had a war tomorrow, would we have enough air crew to be able to man those aircraft on over a week cycle, perhaps, something like that? Your thoughts?
Well, no, obviously not, but it's a very interesting subject. Whilst I was at Air Force Training Group, we were dealing and looking at problems with recruitment. And it came as a massive surprise. Since about 2000, the number of inquiries, the number of inquiries from people, boys and girls, young men and women, who would be suitable to fly with the ADF has dropped from around 1,500 a year down to around 250.
Gee.
We've noticed as well, a couple of things have happened. In the past, on pilot's course, you actually graduated to 2 standards. Even though everybody was above a certain standard, you graduated to 2 standards, and that was those who were judged on pilot's course suitable for fast jets, single pilot aircraft. I'm talking about aircraft like an F-111, like an F-18, Mirage F-35, single pilot aircraft. And then there are others who are judged not suitable for a single pilot aircraft, but more than suitable for a multi-crewed aircraft where you have a whole team to carry out the operational mission. You have a co-pilot so that the junior pilot can spend a period learning. We use the master and apprentice model in flying training. We don't rely on competency-based training, even though it's a good catchword. It doesn't work with flying training. And what we've noticed that in the past, we actually graduated more pilots that were suitable for fast jet than there were billets, than there were seats. So those extra pilots would go off and do a quick tour, maybe on a Caribou, maybe as a co-pilot in a VIP aircraft. Then they would come across to fighters and be retrained as a fighter pilot. The pass rate up until about 2001 was 100% of these additional pilots who we didn't have room for in the fast jet world initially, but certainly they were known and they came across later. Since about 2001, the pass rate of second tour pilots, of re-rolling pilots, the pass rate's been less than 20%.
Gee.
So we spend all this money trying to retrain folks who were judged on pilot's course not suitable for fast jets to come across and fly them. And it's interesting, it points out a couple of things. It points out that the pilot's course that the Defence Force does is a pretty good course to help us determine who's suitable to go where. At the moment, we're not graduating enough pilots who are in that top tier. We don't have enough pilots graduating to fill all the seats. So that's one of the reasons why Jeff Brown, when he was Chief of Staff, and others have followed up, have said, right, let's see if we can increase the awareness of a RAAF flying career. Let's see if we can indoctrinate, if you will, or enthuse some of these air cadets. They've already shown an interest in the Air Force by joining the Air Cadets, so we're going to give them some flying and see if they get hooked. We've got to do something, otherwise what you say is correct. We'll have more shiny toys than we'll have pilots. The engineers are very happy because their aircraft don't get to fly. They're quite happy to have them sit on the ground, but obviously they're meant to fly. We've had other programs in the past. Some of you will be aware that we recruited pilots from other air forces. These were known as lateral recruits. And that's proved, on the whole, largely successful.
Roger, do they know the reason why that second sort of generation of pilots who, up until 2001, 100%?
You know what we did on Saturday?
Sorry, I don't know what happened there. You've gone
No,
somewhere.
Gordon, I understand your question.
You know what we did on Saturday? Yes. This is what I'm doing now.
Someone's running right over the top of us.
This is my normal.
Ron, turn off your microphone, Ron.
The answer to your question is one that's
Yep.
being debated, Gordon.
Right.
When I was instructing, it was my feeling that instrument flying was the best pointer to what was needed on a single pilot aircraft. We would sit the student in the back of the aircraft under a hood, and we would let him fly, and then as his flying skills firmed up, we then start to give him tasks, usually by way of a small abnormal situation. If he was handling that and flying within the limits, then he was going to pass pilot's course. Some people couldn't do that. But then we will give some of them a second task to see if they can reprioritise, to determine what's important, and continue to fly the aircraft accurately. These guys demonstrated to me at the time that they had additional capacity, that they were only using a portion of their time to fly the aircraft and fly them accurately, but had capacity for another task, for an operational task.
Right. Now, I was thinking more in terms of up until 2001, when you sort of retrained the second lot of pilots who had been pilots before,
Yep.
in transport or whatever, and you're getting 100% success rate, and then it dropped to a fifth of that. I don't know why was such a dramatic drop.
Well, I think because the folks who were coming across the re-roll were in that second group. They were judged on pilot's course not to be suitable for fighters, not to be suitable for fast jets. And with the passage of time, because we needed to fill seats, there was a feeling that the additional experience may have negated that prior judgment. My feeling is that it doesn't. But that's a subject that's being debated.
Right.
Everybody doesn't agree with me on that on my view on that.
This is
Roger, David Knight here. Can I ask you, when do you think you will see the last of fighter pilots in general? We're going in that direction, aren't we?
Well, I'm not so sure. We've talked about it for many years, that we would rely on missiles. The some aircraft programs, the Canadian Avro Arrow, the TSR-2 were cancelled in the past because there was a thought that missiles would take over, but still they're designing fighter aircraft. Still they're designing strike aircraft that have aircrew on board, albeit now we're talking about flying with a pilotless aircraft, a wingman that will fly in company with your aircraft to the target. I would say probably not for some time. One of the difficulties we have is in what we call close air support, when we're supporting our ground forces as they move forward. It's a very, very fluid situation where the battle on the ground can go one way or the other, and having aircraft that can respond immediately has proven key. In Vietnam, they came up with a system of forward controlling, with a small light aircraft would be in contact with the troops on the ground. They would have a strike aircraft, and the benefit of the strike aircraft is they carry more bombs. They carry a bigger punch. And they would have them basically orbiting at a holding point just away from the battle area, so that if needed, they could be called in at very short notice, sometimes as close as 5 or 6 minutes away, and there'd be others on the way there. So I don't know.
That only works very properly when you've got full air superiority, of course.
It does, but the benefit of that fourth generation of fighter, the F-18 style fighter, the F-4 was heading in that direction, as I showed you, is they don't just carry bombs. They carry their own defensive weapons, Sparrow, Sidewinder, etc. And even though they may not have their superiority, they probably will have a knowledge of what's going on. If you have your airborne early warning aircraft if you have your AWACS wedge tail up close enough to see what's happening.
Roger, I once hit about 590 knots vertically. I'd started at about 32,000 in my Mustang, and I got what I was termed wing snatching, the right wing.
Yes.
Could you talk about that, please?
I think maybe you might have suffered or experienced what we call compressibility. Very common thing in straight wing aircraft, and one of the major advantages in why they went over to swept wing aircraft. It limited the speed of the straight wing aircraft. And I was just watching a film the other day called, what do they call it? Speed of Sound. It was a British one.
Sound barrier.
Sorry?
Sound barrier it was called.
Sound barrier it was, and they were experiencing this compressibility. And it's a very long and involved subject. But basically, if you've got straight wings, you're going to be limited to its speed.
Would it have had anything to do with the rotation of the air screw?
I don't think so. It's more because, and here's why I say that, Ronald. One of the flights that we do, or we used to do on pilot's course when I was instructing there on the Mackays, was to climb up to around 36,000 feet and dive the aircraft to show the student the effect of compressibility. And I can assure you, it snatched and pulled, and basically the controls stopped working. You had to slow down, or you had to get into denser air at a lower altitude before you could regain full control. So I don't think it's related to the air screw, to the propeller. It's more a
Thank you, Roger.
device.
Thank you very much.
Any more questions?
Warwick here. Roger, F-18s, did you know Stuart Baker Boy?
Yes, I did.
He's Deputy Chief Pilot of Cathay now.
Yes, in fact, Baker Boy was, we were in Saudi Arabia together. He was over in Dhahran on Hawks, and I was in Riyadh on Strike Masters.
One last question, if
Yes,
I may.
Yes.
On the was to do with the Gloucester Meteor. The engines were so far placed out in the wings that if you lost one in a critical position, it was good night. You were not strong enough to stop the aircraft actually rotating.
That's a very good point, Ronald. In fact, it was used, that characteristic was apparently used by some crazy display pilots who would come in quite fast and chop one engine to achieve that desired effect. Obviously, if you fly a multi-engine aircraft, even today, even in a light aircraft, I taught Dave or checked Dave out on my Piper Aztec, if you have asymmetric thrust, the way you counter that is with rudder. And when you push in as much rudder as you can, and it gets to full deflection, if you're going too slow, that deflection will not generate enough force to counter the yawing moment of the engine. Whereupon the only solution you have is to throttle back the good engine. If you've got height, that's fine. But if you haven't, you're in trouble. And the biggest problem with those early aircraft was an engine failure quite soon after takeoff. You can imagine, you have a heavy aircraft full of fuel, and you lose one engine at a slower speed. Really, the best thing you're going to do is throttle back the other one and land on the grass. But because the ejection seats were also limited in those early aircraft. But you're right, they weren't without issue in those early days.
Thank you very much, Roger. I'm very familiar with the situation.
Roger, look, I'd like to say thanks on behalf of your audience here tonight. Most enlightening presentation, to say the least. You covered a hell of a lot of ground very succinctly, I would say. From the evolution of engines to the evolution of airframes, and then we had the evolution of weapons and the evolution of warfare. Besides all that, Roger, I really think it's fantastic you finished up saying at one stage that you still like flying the Windjiel. So, Roger, thank you very much. This was very much appreciated. I think we'll finish the official part of the meeting now. And if you want to carry on for a few more minutes talking, by all means. Thanks, Roger.
Thanks,